as Sky have introduced, I'm Dung Truong, I'm a graduate student at UCSD. And so I'll be going over the tools ecosystem that we built around HED to add with the annotation process and more specifically for EEG data. So the talk outline will involve, first I will go give an overview of the HED tools ecosystem. And then I will give a walkthrough of the BIS and HED tools in EEGLAB, specifically for working with EEG data. I will be demonstrating the usage of the graphical user interface tool CTagger to ease the annotation process. And then I'll show some examples of HED-based analysis for EEG in EEGLAB. So we have been developing a sort of tools in different programming language and environment surround the usage of HED. Kay had mentioned several online tools built in Python that we made available on the headtools.ucsd.edu website, but tools also can be packaged into Python library and can be called in Python directly. We have the schema browser on the web for you to view the schema and search for node in expandable and easy way. So these Python tools can also be called as a web service through REST API. And in fact, annotation analysis tools developed in MATLAB and the CTagger GUI tool leverage these web services tremendously in various features. We also have tools developed in JavaScript and specifically for validating BIS dataset with HED annotation doing upload onto OpenNeuro to make sure that all the BIS dataset with HED annotation upload onto OpenNeuro have valid HED annotation. In the future, we are planning to build tools to work with the online data archive and compute resource NEMAR so that NEMAR user can use HED to search for data set and potentially perform analysis as well. Now, with respect to EEGLAB, the typical workflow from having a BIS data set is to import the BIS data set into EEGLAB study, and then user can review different BIS metadata as well as HED annotation if there is using the BIS MATLAB tools plugin and various menu windows. Then you can again view the HED annotation and add additional annotation using the tool CTagger. Once you have annotated data set, then you can extract ad box using HED tags for downstream analysis. So in the next several slides, I will go through step-by-step of how these look like in EEGLAB menus. Throughout our tutorial, we'll be using the Sternberg working memory dataset that Kay had talked about in her part. This dataset has been published on OpenNeuro, and you can access the dataset and download it directly from NEMAR. So to start with, you need to install EEGLAB, and then once you have EEGLAB installed, then you can install the BIS MATLAB tools plugin and the HED tools plugins. So these are the two plugins that you will be needing to work with BIS and HED in EEGLAB. Once you have the BIS MATLAB tools plugin installed, you can import the BIS dataset using this import BIS folder to study menu. Then you can choose the directory where the BIS dataset stored in, and then you will be prompted for several import options. So you can choose how you want to import the channel location as well as event file, whether you want to extract them directly from the recording or you want to use the BIS file for those information. And then you can specify the directory where you want to store the output of the import. So when EEGLAB import a BIS dataset, it will make a copy of that dataset in EEGLAB format, so that later on you can easily reload them into EEGLAB for further processing. So that's why you specify the study output folder option here. Now, with that, EEGLAB will take care of the rest. And then it will import all the data recording as well as the BIS metadata file into the EEGLAB framework. So once you have an imported BIS data set, you can view different BIS metadata from EEGLAB menu window. So the first window is for you to see the task information of the data set. And this task information pull data from different BIS file, including the dataset description file, dataset description.json, where you have information about the authors, reference and link, department, institution location, so on and so forth. We also pull information from the README file, and then from the EEG.json file for the parameters with respect to the recording configuration for your EEG system. Here just some zoomed in view of this quite dense menu window. And then you can also view BIS participant information via edit BIS participant info menu. So the left panel will give you the view of the participant.tsv file, where each row is a participant, and then each column describes an aspect of that subject. And then on the right-hand side would be the participant.json JSON file, where you describe the column for each aspect of the participant information. And then lastly, you can view general event information from the event.json file in bits. And this, you can see the general description of the column header in the event.tsv file, so that you can have a general idea of the description of the event file. But you will not be using this to view your HED annotation. I will go over the tools that we build specifically for reviewing and adding HED annotation later on. All right, so I want to quickly go over what the event file look like in EEGLAB. So once you import your BIS data set, the event file will be stored in the EEG.event struct. And this structure looks very similar to the event.tsv file. This can be imported from the recording directly, or it would just use the event.tsv file for this information. And so similar to the event.tsv file, each row is a recorded event onset phase marker. And Scott had this, explained to us about how event are processes in full to time, and in our experiment, we have marker that record the onset or the offset or a different transition phase throughout the process. Each column or field in MATLAB or EEGLAB describe a concept of the event with respect to the context of the experiment, and then the field value is in specific aspect of that concept. So for example, in this value field, the a value in this column would describe what was presented on the screen, for example. So in our annotation process, we'll be associating the HED annotation with the fields and field values. And I'll show you how next. I just want to point out to keep in mind is that during the annotation process, we are essentially preparing a single event.json file to be placed at the top level of the BIS dataset hierarchy. So for example, here in the BIS dataset, a BIS directory of the Sternberg working memory, we will be preparing this single task working memory underscore event.json file. All the HED annotation and the description about the event column will be stored in this file, and the annotation will be applied for all the individual event.tsv file within each subject directory. So you only had to prepare, make modification to this one single file, and all your changes will be applied to the entire data set. Our HED tools, again, leverage the online web service. And so this is an example of how you can call the web service from MATLAB but you can also call this web service in Python. So this is very useful if you are a tool developer intended that want to make your tool to work with the HED ecosystem. You can leverage this web service for various functionality to work with HED. So in our case for EEGLAB, we used MATLAB to call the web service through the REST API for various different features. All right, so now let's go into actually viewing and adding annotation, the HED annotation into your data set. Once you have a data set or study loaded on EEGLAB, you can go to edit, add edit event head tags. If you have a single recording loaded onto EEGLAB, then the tool will extract the field and field value presented in your event structure. But if you have a study loaded, then the tool will extract all the fields and their values across all data set and get the combination of them for your annotation. If it was your first time adding head tags to the data set, then you will be prompted to choose the categorical column in the event structure. Mainly because we are annotating the categorical column differently from the value column. So that's why we want to inform the tools in this phase. With that, the C-tagger user interface will show up. And so C-tagger, which stands for community tagger, and the reason why we call that is because this is a tag assistance tool that we want to help the community in using HED. It is a standalone application, so you can call it on its own outside of the EEGLAB ecosystem. But again, as I'm showing here, you can call C-tagger directly from the EEGLAB HED Tools plugin. So this is a graphical tool that we built to help ease the annotation process. So we add various features that would make the annotation process easier for user. Here an example of how you can call C-tagger as a standalone application, not from an EEGLAB environment. So you can download the C-tagger .jar file from our online documentation page. And then once you execute that application, a welcome C-tagger window will show up. And then you can choose the button to import this event dictionary, which is the event.json file. Then this JSON file you can prepare using the online tools that Kay have demoed before to create a skeleton event.json file. And you can choose that file to import into C-tagger to start your annotation. But if you are in EEGLAB, then all that will be handled automatically for you from the dataset. And then, so now you have C-tagger fully loaded. The top panel of C-tagger will be a drop-down menu where you can choose which field you want to annotate. Once you select the field, if it is a categorical field, you will have a left panel showing all the different values within that field. Once you choose a field level, then on the right-hand side will be an editor window where you can enter the head tags associated with that field levels. So one feature that we built in C-tagger is to able to see the head schema in expandable form. So when you have this schema browser window show up, then you can expand different nodes in the schema, and then you can choose a node and see the description of that node and see whether that node would match what you're trying to tag for this particular field level. So the tagging process can simply then be browsing the head schema, browsing the head vocabulary and choose the head term that match your annotation intent. Another features we built into C-tagger is the ability to directly enter the tags, and as users start typing into the editor window, C-tagger will automatically search for tags in the schema that match what had been partially typed in. So right now we only use keyword match, but we are planning to incorporate more advanced feature like natural language processing to help with looking for synonyms or suggesting tags that might have matched what you're trying to describe in the search result. So help the lookup process more convenient for user. Throughout your annotation process, you can at any point choose to review all the annotation that you have for all the field and field levels. And within this window, you can choose to save your annotation into the event.json file so you can share with other people, or you can use that to resume your annotation later on. So here, how you would do that with CTagger, there'll be a file import event.json file, and then you can choose the event.json file you have saved on your local disk to load and resume your tagging. Lastly, you can validate your annotation directly in CTagger to make sure that you have a correct syntax and did not make any typo, so on and so forth. So if you click on the validate all button and you receive the message that say no issue found, your annotation at least valid. Then with that, you finish your tagging for now. A window will show up again to have you review all your annotation. And again, you can later extend your annotation. So just resume the same steps, and then you will resume your annotation. Once you tag your data set, each lab will ask you if you want to save the tagged data set. As shown here, if it's a single recording, if you have a study loaded, then it will save the tags to all the recording of the study. So this is where we store the annotation in the EEG struct of EEGLAB. So this is kind of equivalent to the event.json file, but it's just in a format that only EEGLAB will understand, so that if you are in the EEGLAB environment, then you can resume the tagging process without importing the event.json file. So Kay had showed you how after we add the head annotation to different field and field values, then during the analysis time, the head tags for these will be combined together for each event row in the event file to become the final annotation of that event row. So here I show an example what it looks like in the EEGLAB environment. The annotation that we have put into the field value of the type column and the purpose and the letter will all be combined to become the final hash string for that each row. And it is this final hash string for each row that will be used then for epoch extraction, for lookup of the event for epoch extraction. All right, so we have built the tools in EEGLAB to extract epochs using head tags. It used the pop epoch head function, and the menu window look quite similar to the traditional EEGLAB extract epoch using the lab code, but with the addition of the ability to add in head tags to use as the query. From this menu window, you can choose this button. It will show up a graphical tools that will help you look up all the annotation currently exist in your data set. And then you can choose that as you start typing. So they will make the searching for existing tag much easier in EEGLAB. So you can choose different head tags that you want to use for your epoching. And then you have this head query for your epoch extraction. Once you hit OK, the tools will search for all the event in your annotated event file that would match this head query, and then it will extract those epoch for you. You'll be asked to save the epoch data set, and with that, you have an epoch data set in EEGLAB. So for example, now we have 275 trials extracted from our head query. Now you can do any further downstream processing with this. And so I'm showing an example here of how you can go from this epoch data set into generating an ERP image in EEGLAB you simply choose the plot channel ERP image up menu in EEGLAB, put it in some of your parameters that you want for your app, for your ERP generation, and then you have an ERP generated based on AppBox extracted using HED tags. So instead of using the lab code that might be difficult to understand for other people, now you have a HED tag describing this art image that is more natural and more meaningful. And again, you can, once you have the AppBox data set, you can do other form analysis with it. So here, we show an example of independent component analysis applied to different ladder condition of the Sternberg data set based on the AppBox data using HED tags as well. So in summary, I show you that we have a cohort of tools made available in Python, MATLAB, JavaScript as online website, and also make available at web services for other tools to leverage. Each lab user can work with this data set, having HED annotation using the BizMATLAB tools plugin and the HED tools plugin. I show you the CTagger GUI tools that help ease the annotation process. And CTagger can be both used as a standalone application or as part of the EEGLAB HED tools plugin. And finally, I've shown you the process of going from a HED annotated data set in EEGLAB and extract AppBox using HED tags for downstream analysis. You can check out our online documentation and tutorials on the headexample.readthedocs.io webpage, and all the tools you can download from our GitHub organization repos. And then in the future, we'll be making tutorials on YouTube so that we walk you through step by step each part of the annotation as well as the HED analysis process. I want to mention that the tool is a collaboration of various different people. Kay Robin and her student in UTSA have contributed tremendously into the process of developing the tools. I mainly maintain the tool that relate to MATLAB in EEGLAB. And then we also had Monique working with us to help with the event restructuring tool, which actually she'll be presenting next.